Let's continue our project. Before we move forward, I want to ask everyone a question. This is the current database design, as you can see on this slide. Do you think this is the best entity relationship database design yet? Or we can do something else to keep improving the database design? Let me give you about 30 seconds to think about your answer, and then I will share mine with you. Our current database design works because we can record everything we want into the database. But the problem happens in the product name and per price, these two columns in the orders table. For instance, what if a customer placed another order on iPhone 5s? Then according to the current design, I have to create a new row of data records and then type in iPhone 5s, $599 again. If the third customer places another order on iPhone 5s, I have to repeat the process over and over again. Then we will have a what issue? We will have a data redundancy issue because iPhone 5s, this product name, and $599, this price for iPhone 5s, these two information are already known. According to the current design, we will suffer the data redundancy issue, just like what we talked about at the beginning of this semester. So instead of the current database design, I want to do something to improve it. In this new design, I still have a customers table. This customers table is as same as the one in the previous design. Then I want to create a new table called products. In this table, I want to give each product a unique ID, and then I want to record the name and the price for this product. I can also record something else related to the product. For instance, the category this product belongs to. Next, I want to do some important change on the orders table. I want to call this new order design Order Plus. This is the new table in my database. When a product is ordered by a customer, I want to give a unique ID to this order. And then I want to use cust ID as a foreign key to look up the customers table. I want to know who placed this order. Next is very important. Instead of recording the product name and price for this product over and over again, I want to create another foreign key in the Order Plus table. I call this Pro ID. By using Pro ID, I can look up the products table and then get to know which product is being ordered. So I can reduce the data redundancy issue in my Order Plus table. Lastly, I want to create a column called Quant. I want to know how many of this product is being ordered in this transaction. We can get a lot of benefits from this new design. First, we can continue reducing the data redundancy issue in the Order Plus table. Next, if we have a price change for a product, we don't have to go to the order table and find out all orders related to this product and then change the new price one by one. We just use the Pro ID as a foreign key to look up the products table and then refer to the new price for the product. I didn't introduce this design to everyone at the beginning of this semester because at that time we just get started in SQL Training. Now I think it's a good time to introduce to you because we have learned and get familiar to important concepts such as ER database design, foreign key, inner join, and so on. Now we can keep improving the database design. Let's implement the new design into the database. Let's go to MySQL Workbench and then create a new SQL script. I have already had the customers table in the current database, and I don't want to change anything on this table, so I can keep the current customers table. But I don't have the products table. Let's create one. Let's type in use my site. This means the products table will be saved in the database called my site. And then let's type in create table, products, parentheses. Between parentheses, let's build the structure of this table. First, we want to create a primary key column called ProID. It can host the integer type values. It's not null. And also, we want to add the auto increment property to this column. Auto underscore increment, and then a comma. Next, I want to record the product name. Let's call this product name. We want to use a varchar. I want the user to be able to input up to 200 characters to record the product name. And then a comma. Next will be the price. Per price. Price per product. I want to use a float type. Next will be the category. Category is just some optional additional column. If you want to add additional information about the product, you can add a new column called a category. I want to use a varchar. Up to 200 characters, and then another comma. Next, I want to type in primary key. Parentheses. Between parentheses, let's type in ProID. This indicates I want to use ProID as a primary key column. Now the table is already done. Let's click the lightning bolt to build such a table. Then you will see in the output message, you can see a check sign, a message with a check sign. That means your table is ready in the database. Let's save the script. Let's call this products. Products table. Let's call this products table and then save it. Now let's create a new script to insert information into products. Let's click the create a new SQL script button. We need to use the my site database. Let's type in use my site. And then type in insert into products, right? And then parentheses. Here we need to take care of the product name column, per price column, and then category column for 5 products. Let's list the column's name between parentheses. Product name, comma, per price, comma, category. And then after the ending parentheses, let's type in values. Parentheses. For the first product, it's called the iPhone 5S. Let's type in 2 single quotes and then type in iPhone 5S. And then a comma. The price column holds the float type value. So let's type in 599 directly. And then another comma. Category, we hold the textual data, so we need to type in 2 single quotes. And then type in electronics. This is the information for the first product. Then we can copy the current insert into and then paste it into the new line. We can type in some information for the second product. Second product is a Source Park DVD. Let's copy this information and then remove iPhone 5S and then paste the DVD information between 2 single quotes. This DVD costs $18.66 each. Let's type in 18.66. The category for the DVD is videos. Let's remove electronics and then change it to videos. The second information is done. Next, let's copy it, insert into. Third product is AM Commerce t-shirt. Let's copy this. It costs $12.50 each. 12.5. And the category should be clothing. So let's type in clothing. And then let's copy the current insert into. And then let's see the fourth product, tire compressor. Let's copy this. The price is $29.77. The category should be tools, right? Let's copy the current insert into statement. Let's record the fifth product information, Android Galaxy 8. Let's copy this. The price should be $854. And then the category should be electronics. So let's copy electronics and then change tools to electronics. Now we can click the lightning bolt to save all this information into the products table. You can see in the output window we have a lot of messages with check signs, right? This means the data records have been saved in the products table. If you like, you can save this script as well. Let's save it. Let's call this product records. Next, we need to build the new order table. We call this orders plus, right? Let's create a new script. Still, we need to save the orders plus into the my site table database. So let's type in use my site and then a semicolon and then create table orders plus. You don't have to name it as orders plus necessarily. I just want to create something new to differentiate the new order table from the customer orders table we have had in the current database. Between the parentheses, let's type in order ID. This will be the integer type, not null, auto underscore increment, because this will be the primary key for the orders plus table. Next, we have a cast ID. It holds the integer type value. This will be the foreign key to look up who placed this order, and then a comma. Next, we have a pro ID. Pro ID will be another foreign key to look up what is being ordered. It holds the integer type value as well. And then we have a quant. Quant will hold the integer type value. How many of the product is being ordered in this transaction? Another comma. Lastly, we want to type in primary key, parentheses. In this case, we want to use order ID as the primary key. And then let's click the lightning bolt. And then you will see the output message with a check sign. This means the orders plus data table, this new table, is saved into the database. Let's save this script. Let's call this orders plus table. And then let's create a new script. Let's record the order information into orders plus. Use my site, semicolon. and then insert into orders plus parentheses. Here we need to take care of the cast ID column, comma, pro ID column, another comma, and then quant, and then values, parentheses. Let's take a look at the first order. Cast ID, pro ID, and quant are all ones. So let's type in 1, 1, 1, and then semicolon. Let's copy the current insert into, and then create a new statement to record the second transaction. Cast ID 1, pro ID 2, quant 1. So let's type in 1, 2, 1. And then let's paste the insert into statement. The third transaction, cast ID 1, pro ID 3, quant 4. 3 and 4. The last transaction, cast ID 2, pro ID 4, and then quant 1. When you have new orders, you can paste the insert into statement and then record the cast ID, who places the order, per ID to look up what is being ordered, and then record the quantity of the products being ordered. Let's click the lightning bolt, and then you will see in the output window there are some messages with check signs. That means the order information has been recorded into the orders plus table. Let's save this script. Let's call this orders plus records. Let's save it. Now the e-commerce website manager gives us a more challenging analysis task to do. He wants to know who placed the orders on what kind of products. In the final report, he just wants to see the names of the customers who have placed the order. Also, he wants to see the names of the products that has been actually ordered. The reason is, if you look at the current database, not every customer has ordered the products, right? Not every product has been ordered. So in the final report, the e-commerce manager just want to know the names of the customers who actually placed the order, the name of the products who were actually ordered. How can we achieve this goal? In the inner join lecture, we learned how to retrieve data from 2 tables. Now we have 3 tables. How can we retrieve data from 3 or more tables? We still need to use the inner join statement. Let me show you how. Let's create a new SQL script. Still, we need to use my site. And then we need to use select and asterisk from. We learned how to use inner join to connect 2 table resources, right? But this time, we need to connect 3 tables. And also, if you pay attention to the current design, the orders plus will connect to the customers table. The orders plus will connect to products table, but there is no direct connection between customers table and product table. So let's use orders plus as the focal point to connect to inner join the other 2 tables. Here we need to type in orders plus. And then I want to use orders plus to inner join the customers table. I want to use inner join to connect orders plus with customers. And then I want to look up the cast ID between the 2 tables. Once there is a match, I want to retrieve the data records from the 2 tables. I want to use orders plus dot cast ID equals to. customers dot cust ID. Next, I want to inner join between orders plus and the products table. I want to continue writing it. Inner join products. The second inner join means I want to use orders plus to inner join with products. Similar to the cust ID, I want to use a pro ID between the two tables to make the match. So let's type in orders plus dot pro ID equals to products dot pro ID semicolon. Let's take a look at the result. Let's click the lightning bolt. Now you can see we connect the three tables and then retrieve the information about the customers who actually placed the order and also what kind of products have been ordered, the price for each product, and so on. But the manager is just interested in the customer name and product name. So let's change the statement a little bit. Let's choose cust first name and then a comma and then type in cust last name and then another comma and then type in product name. We need to do these changes after select and then click the lightning bolt. Now we can see who placed what kind of orders. By using the double inner joins, we can connect three or more tables together and still make the correct report, right? We can make the analysis report more useful. For instance, in the final report, besides the customer information and product information, we can use expression to calculate the total price for each order. What we need to do is to change the select statement. After product name, let's type in a comma and then type in per price multiply quant and then type in as total and then click the lightning bolt. Then besides the customer name, product name, we can also say how much each product should be paid by the customer. This is how you use double inner joins to connect multiple tables.